Welcome once again to Think 304 Managerial Economics. In this session, we'll be looking at a tool called game theory. My name is Dr. Japoma Jekedako. Remember in session 10, we looked at strategic behavior and we specifically looked at oligopoly behavior. What we want to do here is that we want to try and model oligopoly behavior. That is modeling the degree of interdependence amongst firms. Now, an important tool that we can use in modeling the degree of interdependence amongst firms or the strategic behavior that firms would adopt when they find themselves in competition is game theory. One thing that I didn't say in the other session is that when it comes to monopoly and monopoly, there's only one firm, so there's really no reason why firms would want to be strategic in their behavior. When it comes to perfect competition and monopolistic competition, because the firms are many in there, strategic behavior is not really going to be useful because your degree of influence over price is very, very minimal. So strategic behavior is very useful as far as oligopoly is concerned, and we are going to be using game theory to model strategic behavior. In particular, what we want to do is to understand what we mean by strategic behavior of firm interdependence, and we are going to also be looking at using game theory to look at how firms would react when there is an action by one firm. As usual, contact Bai and Prince, Managerial Economics and Business Strategy, and look at the 8th edition if that is available. So like I was saying earlier, game theory is an important tool for studying strategic interactions. And game theory is not just limited to managerial economics or economics. It also goes into the behavior of politics. For criminal investigations, they can use game theory. For biology, they can use game theory. And for many disciplines, game theory is very, very useful. However, in economics, it's useful to study extensively the strategic behavior of firms. Now, what is a game? One thing that you should know here is that when we talk about games, running a business is just like playing a game, and you can't take that away from it. If you're running a business, it's like you're playing a game because there are other players in the business which you have to take into account. So whatever managerial decision you're making, you have to make sure that those players have been taken into consideration. Now, a game is just like a competition in which you would find winners or you'd find losers. So a competition that has rivals that are playing up is what we would call a game. Now, every game has its rules. So in a game, you can think of the number of players, you can think of what you can do and what you cannot do. So every game has its rules. Now, a game would have a winner and it would have a loser. It's not always that the person who is strong or who is fast or who can do things the right way ends up winning the game. No. It's all about the person who understands the rules of the game that would go with the crown at the end of the day. So it's important that if you are playing a game, you make sure you understand the rules of the game. So like I've said, every game has a rule. And so in operating firms, you need to understand the rules in which you are playing that game that you are playing. We have what we call a simultaneous game, and then we have what we call a repeated game or a sequential game, sorry. Now, a simultaneous game if you take the word simultaneous, it just means that doing something at the same time. But here, when we talk about a simultaneous game, it doesn't necessarily mean that you are playing the game at the same time. What it means here is that whatever you are doing is not being seen by the other party to the game. So you may be playing the game, but you play yours, the other person would play his at another time, but you both will not be seeing what the other each other would be doing, or what you'd be doing on the sides. That makes it a simultaneous game. A sequential game is a game that is played, and then afterwards one person plays, and then afterwards another person would play. Now let's look at some basic concepts under games. Players, in every game there's a player. And who are the players? The players are the decision makers in the game. In every game, there are strategies, and the strategy would refer to the various actions or moves available to the players during a game. So whatever move each player would make is what it would be called the strategy. And then there's a payoff. Of course, you not play any game because you want to play. You are playing the game because there's a reward that is attached to the game. So here, if you are playing a game, there's going to be a reward that you are getting. Now the reward here can be a positive reward, or it can be a negative reward as far as firm operations are concerned. So it's very, very important that you take that into consideration when making your decisions. So the strategies as far as firms are concerned could be any move that the firms are making. Move in terms of how much output to produce, move in terms of how much price to charge, move in terms of how much advertising to do. And the payoff could be in the form of profit, it could be in the form of market share, and it could be a penalty for not really doing something. So remember, the payoff is really not always positive. There are some other concepts that you can read on pure strategies and mixed strategies. Now, how are games represented? Games can be represented in normal form, or they can be represented in extensive form. What do I mean by normal form? If you have a game that shows the players and the different strategies and the payoffs in a tabular form, we say that that game has been represented in a normal form. And if you have a game that is represented in a form of a tree diagram, you say that the game is being shown as an extensive form. This is a typical example of a game that is being represented in the normal form. So you have the players. The players here are Talu and Energy Company, and then the strategies are whether they should play narrow or wide. Those are the strategies. And here you can think of it in terms of profit. If they played narrow or wide, their payoffs are given in the brackets here. So it's really, really crucial that you get to know how these payoffs are explained. So here, energy has, if energy is playing, right, its payoffs will be shown in the row form. And then if Talu is playing, its payoffs will be shown in the column form. So here, if energy is playing narrow, its payoff is 15 when Talu is playing narrow, and then its payoff is 0 when Talu is playing wide. If energy is playing wide, its payoff is 17 when Talu is playing narrow, and then its payoff is 0 when Talu is playing wide. In the same way, if Talu is playing, we are now looking at the columns, and is playing narrow, its payoff is 15 if energy is playing narrow, and its payoff is 0 if energy is playing wide. If it's playing wide, its payoff is 17 if energy is playing 0, and 0 if energy is playing 0. It's really important that you understand how this plays out. So really, if it's a market share game they are playing, you can have, and it's a simultaneous move game, then you can have two managers who would want to maximize their market share, and the strategies here are the pricing decisions. So here, manager 1 is here, manager 2 is here. Manager 1 will be taking the columns, and manager 2 will be taking the rows. And the strategies are either charging a price of 5 or charging a price of 15. And you can think of how the payoffs are structured based on how I explained to you earlier on. Now, game theory was initially brought about to model what we call the prisoner's dilemma, where two prisoners, so this doesn't really apply to the firms I'm talking about here, but it's going to really help you understand exactly how game theory is applied in businesses. So two criminals went to commit a crime, and then when they went to commit the crime, some way, somehow, they were arrested. Now, they were arrested, but they were not caught in the act. So the let's say the criminal investigation department wanted to find a way of making them confess to the act. And what did they do? So they were obviously they obviously were confronted with two strategies, either to confess or not to confess. But this was a simultaneous move game, which meant that what the other criminal 1 was going to be doing would not be seen by what criminal 2 was going to be doing. And so they were presented with options based on the strategies: confess or do not confess. And they were given payoffs. Remember what I said, under this circumstance, the payoffs are in the form of prison sentences. So it's a negative payoff. And so the less years you get in jail, the better it is for you. Okay, so your idea here is to maximize your utility as a player. So there's player 1 and player 2, or both confronted with confess and don't confess. So if player 1 confesses and player 2 confesses, they are both going away with 6 years in jail. If player 1 confesses but player 2 does not confess, then player 1 would be set free, but player 2 would have 8 years in jail. If player 1 does not confess, but player 2 confesses, player 1 will go with 8 years, player 2 would be free. If both don't confess, then they are going to be having 3 years in jail. I mean, ideally, you would say that both of them should not confess, and then they would have 3 years, and that would be okay. However, or you would hope that player 1, if you are player 2, you would hope that player 1 will not confess, and you'd confess, and you'd be asked to go home. The key here is that nobody is being told what the other person is going to do. So you would want to maximize your own welfare. What can you do to maximize your own welfare? This principle can be applied in the behavior of firms as well. We'll come back to look at what actually both players ended up doing. Now we can talk of a dominant strategy if we want to understand the decision that the firms are going to be making, or the players are going to be making. A dominant strategy is a strategy for a player if it gives that player the highest payoff, irrespective of what that player, irrespective of what the other player does. So irrespective of what one player does, if a strategy gives you the highest payoff, then you can consider that as a dominant strategy. Another thing that you can also look at is what we call the Nash equilibrium. The Nash equilibrium is, so here you would want to reach an equilibrium. We define Nash equilibrium as a state where both sides of the market are happy with the existing market outcome, and that they can't get any happier with any other option that they choose. So let's go back to the prisoner's dilemma and see whether each firm, any firm, has a dominant strategy. So what do we say about dominant strategy? We said that it is the strategy that a firm or a player would go with irrespective of what the other person does. So let's see, player 1. Okay, let's take player 2. If player 2 decides to confess, what would be the best response for player 1? If he decides to confess, the best response for player 1 in terms of jail sentences will be to confess, because 6 is smaller than 8, and really that's what you want. If player 2 decides not to confess, the best response for player 1 is also to confess. So you see here that irrespective of what player 2 does, player 1's best response is to confess. Let's look at player 1. If player 1 decides to so it means that the dominant strategy for player 2 is to confess. If player 1 decides to confess, the best strategy for player 2 is also to confess. If player 1 decides not to confess, still the best strategy for player 2 is to confess. It tells you that player 2 has the best strategy, or the dominant strategy, being to confess. So both players have the dominant strategy to confess. In that case, the Nash equilibrium will be to confess for player 1 and to confess for player 2. We've solved the game. So 6 years is what they really have to settle for. Ideally, 3 years would have been better for them, but you are not sure what the other person would do. So to maximize your own welfare, you have to make sure that you go with confess, which is 6 years. Now we see that 6 years is the equilibrium, but it's not the desirable equilibrium here. So it tells you that Nash equilibrium is not usually is not necessarily the most desirable equilibrium, but it's the best outcome that you'd have over here. And when you get there, you have no tendency to change anything. This ends the slides. You can try with the other ones and the session, and you can try the other examples that you have. Do not forget to use your textbooks and any other material you come up with. Thank you for your attention.